So this question, we are told that a resistive force acts on an object moving at speed in a stationary fluid of constant density. And so that is our relationship, the force being proportional to the velocity squared, where k is a constant. State the derived units. Now, whenever we see an adjective, we always want to ask ourselves, well, what could the other adjectives be? And the other adjective would be fundamental. Now, fundamental units are the base units. There are only 7 of them. So kilogram, meter, seconds, mole, amps, Kelvin. That's it. So that's fundamental. So derived in this case means the units that come out of using those, either things like meters per second or newtons. In this case, the derived units of force are newtons. The speed and the velocity, the speed is meters per second. So we want to determine the units of k. The units of k, in this case, we will take the equation, kv squared, we solve for k, and that is f over v squared. Well, the units of f are newtons, and the units of velocity are meters per second. That's a meters per second quantity squared. So that takes us to newtons times quantity, seconds per meter squared. And so that is newtons seconds squared per meter squared. And those are the units of k. Now, if we were going to do the fundamental units, it's a little trickier. The units of force, let me just do that in green, are kilogram meters per second squared. And that then is going to be over meters per second quantity squared. And so kilogram meter per second squared times seconds per meter quantity squared is kilogram meter second squared over second squared meters squared. And so that meters goes away, that squared goes away, these goes away, and we're left with kilograms per meter. And so this is the answer we are most looking for, and this is the answer in the fundamental. Now, I suppose one could argue that, well, just as meters per second is derived units, newtons is derived kilogram meters per second squared. So it means then that the question itself is ambiguous. Well, whenever there's ambiguity, show a more thorough answer. Show both. So by including both of these, it doesn't matter how the rater interprets it or how what the question is intended. You have shown that you understand how to do dimensional analysis. You may actually show that you outsmarted the ambiguity in the question by including both. And that's how we would do a 22.